Hello everyone, welcome to Maths Wheels. In this session, we will study quadratic equations and various ways of finding their roots. And we'll also see some applications of quadratic equation in real life situations. So let's get started. In earlier sessions, we have studied different types of polynomials. One type was the quadratic polynomial of the form ax square plus bx plus c, where a not equals to 0. When we equate this quadratic polynomial to 0, we get quadratic equation of the form ax square plus bx plus c equals to 0, where a not equals to 0 and where a, b, c are real numbers. A question may come to your mind that where is this quadratic equation used in real life situations? I'll give you an example for this. For example, suppose a charity trust decides to build a hall having carpet area 300 square meter. So let's say this is the hall having carpet area 300 square meter with length one more than twice the breadth of the hall. So this is the breadth of the hall and this is the length of the hall. Now if we want to calculate what is the length and breadth of the hall, how to do it? Suppose breadth of the hall is x meter. So this is suppose x. What would be the length of the hall? It would be one more than twice the breadth. So it is 2x plus 1 meter. Right? So what is length? 2x plus 1. That means it is one more than twice the breadth of the hall. Okay. Now what would be the area of the hall? Is length multiplied by breadth, right? So what would be the area here? 2x plus 1, which is length, into x, which is breadth, meter square. Now we know the area of the hall is 300 square meter. So we can write area as 300 and we can solve this equation. So 2x multiplied by 2 and 1 multiplied by x, 2x square plus x. So what is the final equation we get? 2x square plus x minus 300 equals to 0. So this is the quadratic equation we got. And using this, we can calculate length and breadth of the hall. So this is how quadratic equations are used in real life situations. What is the standard definition of quadratic equation? A quadratic equation in the variable x is an equation of the form ax square plus bx plus c equals to 0, where a, b, c are real numbers and a not equals to 0. We simply have to equate the quadratic polynomial with 0, we get quadratic equation. In other words, we can say any equation of the form p of x equals to 0 is a quadratic equation where degree of this polynomial is equals to 2. That means this polynomial should be quadratic polynomial. When we equate it to 0, we get quadratic equation. Let's take one example and let's solve it. There is one situation given in this example and we have to represent this situation mathematically. So what is the question here? Represent the following situation mathematically. John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. Find out how many marbles they had to start with. Let's find the solution for this. Now, if you read it properly, John and Jivanti together have 45 marbles. So, let number of marbles with John equals to x. So, what would be the number of marbles with Jivanti? It would be equals to 45 minus of x, right? Because they together have 45 marbles. John have x, so Jivanti would have 45 minus x. Now, when they lost 5 marbles each. Okay. The number of marbles with John would be x minus 5, and the number of marbles with Shivanti would be 45 minus of x, so 5, so that would be 40 minus x. And we have the product of the marbles is given in the equation. So this product we have given x minus 5 into 40 minus x is given as 124. Let's solve this. X multiplied by 40 and x with 40x minus x square minus 200 plus 5x equals to 124. Solving this, solving the constant terms here, this 200 will go to the right and it would be 324. Solving this, we will get the quadratic equation x square minus 45x plus 324 equals to 0. So this is the mathematical representation of the situation given. Mathematical representation. We can say the number of marbles John had satisfies this quadratic equation, and hence this is the mathematical representation of the problem. Next is second type of question that may be asked in the exam. It is check whether the following are quadratic equations. For this, before deciding whether it is a quadratic equation or not, we need to simplify the given equation. And we need to verify whether the given equation is of the form ax square plus bx plus c. What we need to verify? The given equation is of the form ax square plus bx plus c equals to 0. Let's solve first example. First, we need to simplify this equation to decide whether it is a quadratic equation or not. So what is the left hand side? Left hand side is x minus 2 whole square plus 1. So if we simplify this, we get x square minus 4x plus 4 plus 1. Again, if we simplify this, we get x square minus 4x, 4 plus 1 is 5. Now what is the right hand side of this equation? 2x minus 3. So this is already in the simplified form, so we don't have to simplify it again. So here we have simplified both left hand side and right hand side. Now what we get final? X square minus 4x plus 5. Left hand side equals to right hand side, right? Now if we simplify this minus 4x and 2x, what we get? X square minus 6 of x plus 8 equals to 0. So this is the final simplified form of the given equation. Now if you observe, this equation is in the form ax square plus bx plus c equals to 0, which is the standard form of the quadratic equation, right? So can we say if this is a quadratic equation or not? Yes, this is a quadratic equation. Now let's solve second equation. What is the left hand side of the equation? X into x plus 1 plus 8. Now if we simplify this, we get square plus x plus 8. Now what is the right hand side of the equation? It is x plus 2 into x minus 2. Now if you observe, this is in the form a square minus b square equals to a plus b and a minus b, right? So if you simplify this, what we get? X square minus 2 square. So that would be x square minus 4. Now let's equate left hand side and right hand side. What we get? X square plus x plus 8 equals to x square minus 4. Okay. Now if we simplify this equation, this x square gets cancelled. What is left out? X plus 12 equals to 0. Now if you observe this equation, is this equation in the form ax square plus bx plus c? No. So we can say this is not a quadratic equation. Now let's solve third example. what is the left hand side? It is x into 2x plus 3. If you simplify this, what we get? 2x square plus 3x. Now what is the right hand side? It is x square plus 1. Now let's equate both left hand side and right hand side. What we get? 2x square plus 3x equals to x square plus 1. Now this x square, if come to left hand side, it would be 2x square minus x square. So we get x square plus 3x minus 1 equals to 0. Now if you observe this equation, this is in the form ax square plus bx plus c equals to 0, right? So we can say this is also a quadratic equation. Now let's solve fourth example. What is the left hand side? Plus 2 whole cube. Now using the formula a plus b whole cube, we get x cube plus 6x square plus 12x plus 8. So this is in simplified form now. What is the right hand side? It is x cube minus 4. Now let's equate both left hand side and right hand side. What we get? X cube plus 6x square plus 12x plus 8 equals to x cube minus 4. Now if you simplify this, 6x square plus 12x plus 12 equals to 0. Now this equation is also in the form ax square plus bx plus c equals to 0. So we can say this is also a quadratic equation. Now if you observe second equation, it appears to be a quadratic equation. But after simplifying it, we identified it is not a quadratic equation. Now if you observe fourth example, it appears to be a cubic equation since the degree is 3 here. But after simplifying, we identified it is a quadratic equation. So you need to remember that before deciding whether it is a quadratic equation or not, we need to simplify the given equation. Next concept is solution of a quadratic equation by factorization method. Before we understand the solution of a quadratic equation, let's first try to revise the concept of zero of a polynomial that we learned in earlier sessions. What is a zero of a polynomial? It is the value of the variable for which the value of the polynomial becomes 0. For example, let's take a quadratic polynomial 2x square minus 3x plus 1. Now suppose if we substitute the value of x as 1, what we get? 2 into 1 square minus 3 into 1 plus 1, that is equals to 0. So when x equals to 1, we get the value of the polynomial as 0. So this 1 is called the zero of a polynomial. Now if we equate the same polynomial to 0, what we get? We get a quadratic equation, that is 2x square minus 3x plus 1. This is our quadratic polynomial. Now we are equating it to 0. This would give us the quadratic equation. And now if we substitute x equals to 1, we get same value as we calculated in above polynomial, that is left hand side equals to right hand side, that is equals to 0. So when x equals to 1, we got left hand side equals to right hand side equals to 0. So this 1 is called the root or the solution of quadratic equation. Now for a quadratic polynomial, we learned earlier that there can be at most 2 zeros. for a quadratic polynomial. Same is the case for quadratic equation. There can be at most two roots for a quadratic equation. We can say in general alpha is called root of quadratic equation ax square plus bx plus c, where a not equals to 0 if a alpha square plus b alpha plus c equals to 0. And how we got this equation? When we substitute x equals to alpha. So this x equals to alpha is called solution of the quadratic equation, and alpha is called root of the quadratic equation. We can also say that alpha satisfies the quadratic equation. Now we have understood what is the root or solution of the quadratic equation. Now we will find the roots of the equation by factorization method. We have learned in class 9 how to factorize quadratic polynomials by splitting the middle terms, right? So we will use the same knowledge for finding the roots of the quadratic equation. Let's find the roots of the equations by factorization method. Let's take first example. It is 2x square minus 5x plus 3 equals to 0. Let's first split the middle term in such a way that we get product as 6. Coefficient of x square and the constant, if we multiply this we get 6, right? So 6 here is multiplication of 2 and 3. We need two numbers whose multiplication is 6 and addition is minus 5. What can be those numbers? It's minus 3 and minus 2. Let's put those numbers in the quadratic equation. What we get? 2x square minus 3x minus 2x plus 3 equals to 0. Let's take x as common. What we get? 2x minus 3 minus, let's take 1 as common, we get 2x minus 3 equals to 0. Now let's take 2x minus 3 as common. It is left out, x minus 1 equals to 0. Now to find the roots of this equation, we need to equate each of these terms to 0. So 2x minus 3 equals to 0 and x minus 1 equals to 0. So if you solve this, you get x equals to 3 by 2 and here x equals to 1. So 3 by 2 and 1 are the roots of this quadratic equation. Now let's take second example. 6x square minus x minus 2 equals to 0. Here the product of 6 and minus 2 is minus of 12. Let's split this into two numbers in such a way that we get addition as minus of 1. So this is our middle term, right? So let's split this. What can be these numbers? 3 and minus 4. So the multiplication of 3 and minus 4 is minus 12 and addition is minus of 1. So let's put those values in the quadratic equation. What we get? 6x square plus 3x minus 4x minus 2 equals to 0. So if we take 3x as common, we get 2x plus 1 minus of, let's take 2 common, we get 2x plus 1 equals to 0. Now from this, if we take common 2x plus 1, what is left out? 3x minus 2. Now let's equate each of these terms to 0. 3x minus 2 equals to 0. So what is the value of x here? Minus 1 by 2. And what is the value of x here? 2 by 3. So minus 1 by 2 and 2 by 3 are the roots of quadratic equation.